1 gigawatt. I just want you to sit with that number for a second.
Yeah.
That is roughly the energy output you need for a mid-sized city or, yes, a nuclear power plant. Usually, when we talk about that kind of power, we're talking about heavy industry, maybe national infrastructure.
Right.
But as of this week, early February 2026, we are talking about a single AI cluster.
It's a staggering figure. I mean, we aren't just talking about a data center anymore. We're talking about a machine that effectively requires its own dedicated power grid. Meta calls it Prometheus, and it changes the definition of scale.
Welcome back to the Deep Dive. This week is all about Meta, and frankly, it's a week of extremes. We're looking at the most massive physical infrastructure project in AI history with Prometheus. And at the same time, we're looking at these really intimate human-scale research projects involving veterans and memory loss, plus a very messy, very high-stakes fight with the European Union.
It really is a study in contrast. On one side, you have the brute force physics of how do you even cool a gigawatt cluster? And on the other, you've got the nuance of policy. Who gets to control the software running on top of it all?
Exactly. So here's the roadmap for today. We're going to start with the research, specifically a model called DynoV2. That is, believe it or not, mapping forests, then the Aria Glasses project for cognitive assistance.
Okay.
Then we need to get technical with the developer updates. We're talking PyTorch, Helion, and a new app called Vibes.
Right.
After that, we are doing a deep technical breakdown of that Prometheus cluster, because the networking required to make it work is actually more interesting than the power usage itself.
Well, absolutely. The fabrics are key.
And we'll close out with the geopolitical landscape,
Right.
that EU antitrust case, and some fascinating economic data out of Canada. So let's start with the research. I want to look at DynoV2. We spend so much time talking about generative AI, making videos, writing poems. But DynoV2 is different. This isn't about creating new data. It's about understanding what's already there.
That's a critical distinction. DynoV2 is a discriminative model, not a generative one. Its whole job is to look at the world and understand the geometry, the texture, the relationship between objects.
And the news this week is that Meta has deployed this with the UK government.
Yeah, to map forestry and track tree health.
But the breakthrough here isn't just that it can see trees, it's how it learned to see them. Usually, to train a vision model, you need an army of humans labeling images. This is a leaf, this is bark.
Right. Endless labeling. DynoV2 didn't need that. It uses what's called self-supervised learning. And we should probably clarify that term because it's becoming the standard.
Wait.
So instead of a human telling the model, this is a tree, the model takes an image, it masks out or hides random parts of it, and then it tries to predict what's missing based on the parts it can still see.
So it's playing a game of fill in the blank with millions and millions of images.
Exactly. If it can accurately guess that a rough brown vertical shape connects to a green leafy canopy, it starts to understand the concept of a tree. It learns the structure of the data itself.
Without a single human label.
Without one. And that makes it incredibly cheap to deploy for things like, government surveys.
Which is why they're calling this sovereign utility. It's moving AI from an entertainment product to a tool for managing national resources.
Yeah.
Okay. Shifting from the forest to the living room, let's talk about the Aria Gen 2 update.
The partnership with the Oscar Mike Foundation.
Right, for veterans.
This is one of those applications where the hardware kind of disappears and the utility just takes over.
Yeah.
We're not talking about the Ray-Ban Metas you can buy in a store.
No, these are the Aria research classes. They're packed with more sensors for things like eye tracking and spatial awareness. The goal here is helping veterans with traumatic brain injuries or TBIs.
And the specific use case is what they call a cognitive exoskeleton, which I think is just a brilliant term.
It is. It's not just about recording. It's about active assistance.
Think about the daily friction that comes with a TBI. It often involves memory lapses, maybe difficulty with spatial orientation, or executive function issues, like getting distracted halfway through a task.
Sure.
The Aria glasses are running this multimodal AI that sees what you see and hears what you hear. So if a veteran is trying to take medication but gets interrupted by a phone call and forgets, the glasses can visually or audibly nudge them back to the task.
It's acting as an external working memory.
Precisely. It can answer questions like, where did I leave my keys? Or what was the name of the person I just spoke to? Because it has the context window of your day. It's restoring a layer of independence that the injury took away.
That distinction moving from smart glasses that take photos to assistive devices that effectively patch I don't know, software bugs and human cognition. That feels huge.
It is.
Now, before we get to infrastructure, some significant updates for the builders, for the developers. First, let's talk Llama.
Llama 3.18b, the little model.
Right. Meta released a recipe to, quote, unlock reasoning in this smaller model. Now, we've seen reasoning models from OpenAI with O1 from Google. This is usually done via chain of thought. What exactly did Meta release here?
So they released the recipe for fine-tuning the model using synthetic data to generate what they call thinking traces.
Okay.
Normally, a model just predicts the next word to give you an answer. With this update, the model is trained to actually output its internal monologue, the step-by-step logic it uses to reach the conclusion.
So it shows its work.
It shows its work, but more importantly, the training data they used to teach it this behavior was synthetic. They didn't have humans write out millions of logic puzzles. They used a larger model to generate the reasoning steps, filtered those for quality, and then used that to teach the smaller 8B model how to think.
That's the efficiency play. You get the reasoning capability of a massive model, but it's distilled down into a model small enough to run on a single GPU, or even on edge hardware.
Exactly.
Speaking of efficiency, we have to talk about PyTorch. There were two updates that might sound like jargon salad to most people: Helion and torch.export. Let's translate these.
Okay, this is really about the maturation of the AI stack.
Yeah.
Let's start with Helion. If you're writing high-performance AI code, usually you have to drop down into C++ or UDA to write kernels, the actual math operations running on the chip. Python is just too slow for that.
But writing CD is a nightmare for most data scientists.
A total nightmare. So Helion is a domain-specific language, a DSL, that lets developers write these high-performance kernels in something that looks a lot closer to the Python they know, but it compiles down to highly efficient machine code.
So it's about making it easier to write fast code.
Right. It's especially useful for things like page detention, which is a technique for managing memory when you're serving LLMs to thousands of users.
And what about torch.export?
That's about getting that code out of the lab and into production. Historically, PyTorch used something called TorchScript to save models so they could run without Python. But it was brittle.
I've heard that.
Yeah. Torch.export is a new, more robust standard. Meta is using this for their recommendation systems, the algorithms that decide what reel you see next. Those systems handle hundreds of queries per second. They just can't afford the overhead of Python. Torch.export strips all that away so the model runs purely on the inference engine.
It effectively hardens the model for the real world.
Okay. One last product note before the infrastructure deep dive. Vibes. I saw the headlines on this, and I immediately thought, they are coming for TikTok's creator tools.
They absolutely are. Vibes is a standalone app. Meta is testing for AI-generated short-form video. It used to be just a feature inside Meta AI, and now it's spinning out.
That feels like a strategic shift, doesn't it? If it's a feature inside Instagram, it's a utility. If it's a standalone app...
They're trying to build a new behavior.
Yeah, they want to capture the generative creator. Right now, if you want to make a crazy AI video, you might go to Sora or Runway or Kling. Meta wants that happening in their ecosystem. And by isolating it in a separate app, they can iterate faster and probably eventually charge a subscription for it without cluttering up Instagram.
The creative suite strategy. Okay, let's pivot. The main event, Prometheus, the gigawatt cluster. We established the scale as like a nuclear reactor's worth of power. But the complexity here isn't just plugging it in, it's the network.
Right. If you just take, say, 30 or 50,000 H100 GPUs and you spread them out across 10 different buildings because one building can't hold them, you have a physics problem. The speed of light is too slow.
Latency.
If GPU A in building 1 needs to send a gradient update to GPU Z in building 4 and it takes too long, the entire training run just stalls. The chips spend more time waiting for data than they do computing.
So Meta introduced Backend Aggregation.
It sounds like a simple acronym, but the specs are just insane.
This is a network layer that sits above the buildings.
Think of it as a superspine. It's a centralized Ethernet-based network that connects all these separate buildings into what looks like one single logical computer. We are talking about capacities in the petabit range.
A petabit is 1 million gigabits.
1 million. Specifically, 16 to 48 petabits per second per region. It's a fire hose of data so large it's hard to even comprehend. But here's the really clever architectural nuance.
Go on.
BAG connects two different types of network fabrics. They realize that not all AI traffic is the same.
This is the scheduled versus non-scheduled distinction.
Exactly. You have the DSF, the disaggregated schedule fabric. This is for training. Training traffic is predictable. You know exactly when the data needs to move. It's like a marching band. Everyone steps at the same time. You
Hmm.
need perfect synchronization.
I know that one.
Is the NSF non-scheduled fabric. This is for inference, data processing, checkpointing. This traffic is bursty. It's chaotic. It's more like a highway during rush hour. You don't know when a car's going to merge.
So BAG is like a master traffic controller that lets these two totally different types of data flows coexist across multiple buildings without crashing the whole system.
That's the magic.
Yeah.
By separating these fabrics but connecting them through this massive petabit pipe, they can treat the entire region, multiple buildings, as if it were one single computer. This is the only way you can train the next generation of models. Llama 4, Llama 5, these are going to be trillion parameter models.
You physically can't fit the computer needed to train them in one room anymore.
You can't. You have to break the walls of the data center.
It's engineering at a scale that is, effectively re-terraforming the landscape.
Hmm.
But while Meta is building this god-tier machine, they're running into some very human, very bureaucratic walls in Europe.
Yes, the EU versus WhatsApp.
This is a pretty significant escalation. The European Commission issued a statement of objections regarding the Digital Markets Act, the DMA. The core accusation is that WhatsApp is a gatekeeper and it's stifling competition.
And the specifics are about the business API, right?
Yeah. Exactly. So if you're a business using WhatsApp to talk to customers, you might want to use an AI agent to handle those chats, maybe one powered by ChatGPT or Perplexity. The EU alleges that Meta has changed the terms of service to make it technically or contractually impossible to use those third-party bots.
So they're forcing businesses to use Meta's own AI or nothing.
That's the accusation. It's the classic platform privilege argument. Apple does it with the App Store, Google with search. Meta says, we built the house, we set the rules. And the EU is saying, your house is so big, it's now a public utility, so you have to let everyone in.
And the EU isn't just investigating. They're threatening interim measures.
Which is the legal equivalent of an emergency injunction.
Exactly. They're arguing that if they wait 2 years for a court case to finish, the competitors will already be bankrupt. They want to force Meta to open that API now.
And Meta's defense is likely what? Privacy and security risk.
It's always the defense. We can't secure the messages if we let third-party code run on the platform. But the EU is getting increasingly skeptical of that argument when it so conveniently aligns with monopolizing a market.
It's a battle for the interface layer. Meta knows whoever controls the chat window controls the user. Meanwhile, in a totally different kind of safety effort, Meta launched a huge campaign in India.
The Scam Si Bacho campaign. Protect yourself from scams.
This is less about antitrust and more about, well, trust.
India is Meta's largest market by user count. But it's plagued by sophisticated fraud things like digital arrest scams where criminals pose as police on video calls or fake job offers. Meta is using high-profile Bollywood figures like Neena Gupta to educate users.
It's a good reminder that while we talk about gigawatt clusters in the US, the day-to-day reality of AI for a billion people is often, is this video call real or is it a deepfake trying to steal my money?
That is a sobering reality check.
So to wrap up, let's look at the economic argument Meta is making. There was a report this week, commissioned by Meta and the Linux Foundation, focused on the Canadian economy.
The numbers are flashy. They claim AI could add 9% to Canada's GDP by 2035, create 35,000 innovation jobs. But if you read between the lines, this is basically a lobbying document for open source.
How so?
The argument they're making to the Canadian government, and really to all governments, is that open source is the only way to avoid what I'd call the intelligence rent trap.
Explain that.
If Canada's economy runs entirely on closed models, like GPT-4 or Gemini, then every single time a Canadian company wants to use AI, they pay a toll to a U.S. tech giant. That's money leaving the Canadian economy.
Right, it's an export of capital.
But if the models are open source, like Llama, a Canadian startup can download the weights, run it on their own servers or a local cloud, and build their business without paying that perpetual rent. The report argues that open source lowers the entry tax for small and medium businesses.
It allows for a kind of economic sovereignty. You own the brain you're using.
Exactly. And frankly, it's a smart pivot for Meta. They're under fire for being a monopoly in social media, so they are positioning themselves as the liberators of AI infrastructure. We're giving you the tools to be independent, they say, while their competitors are selling subscriptions.
It's 4D chess.
Yeah.
Build the biggest proprietary machine in the world, Prometheus, but give away the software weights to undercut your rivals' business models.
That is the strategy.
We have covered a massive amount of ground today, from the petabit scale networking of the Prometheus cluster to the self-supervised learning of Dino V2 saving British forests. We looked at Aria glasses giving veterans a cognitive safety net.
And the EU trying to tear down the walls around WhatsApp. It's a week that really highlights the physical and political footprint of this technology. It's no longer just software on a screen. It's power grids, it's international trade law, it's medical devices.
And the question I want to leave you with is this. We're seeing the centralization of hardware, these gigawatt clusters that only a few companies can build. And at the same time, we're seeing the decentralization of software open weights that anyone can use. So which force wins? Does the hardware monopoly eventually strangle the open software, or does the open software make the hardware just a commodity?
That is the conflict that will define the next decade.
We will be watching it play out. Thanks for listening to The Deep Dive.
See you next time.